In this video, we're going to talk about Chapter 1, Introduction to Computers and Programming. People use computers at work, at school, and home to do multiple tasks. What are some of the ways you use a computer? Devices that are computers are smartphones, iPad, tablets, car navigation systems, as well as a bunch of other kind of devices. Can you think of some other devices that are computers that you may use? Computers are designed to do any job that the programs tell them to do. A program is a set of instructions that will perform a task. An example is Word and PowerPoint. Programs are also commonly referred to as software. Think of the number of softwares you have used. Programmers and software developers are the people that create the computer software. They have the training and skill to design, create, and test the computer programs. Hardware and software. The physical devices that a computer is made of are referred to as the computer's hardware. The programs that run on a computer are referred to as the software. A computer is a system of devices that works together. Hardware consists of CPU, main memory, secondary storage, input devices, and output devices. The CPU is part of the computer that runs the program, also referred to as the processor. Without it, a computer cannot run software. Running it or executing a program is the term used when the computer performs the task that the program tells it to do. Hardware history starts back in 1945 with the world's first programmable computer. You can see figure 1-3 how big it is. Microprocessor, much smaller, much more powerful. Figure 1-4 shows a modern microprocessor. Main memory is considered the computer's work area. The computer stores the program that is running as well as the data. This is commonly referred to as RAM, random access memory. The data can be quickly accessed. It's volatile, though, which means if the power goes out or it freezes up, you lose everything in RAM. It's only used as a temporary storage. When the computer's turned off, it is erased. Read-only memory. A computer can read the contents of ROM, but it cannot change its contents or store additional data there. ROM is non-volatile, which means it doesn't lose any contents when the power goes off. It is typically used to store programs that are important for the system's operation, such as the startup program. Let's talk a little bit how the RAM works. When you start up your computer, the operating system is copied into RAM. When you open up an application, that application is copied into RAM. If it's a Word application, you're creating a document, that document is created in RAM. If you're creating a spreadsheet in Excel, that spreadsheet's created in RAM. They don't move out to your hard drive until you do a save. Once you save it, then you got two copies of it. You got one in RAM and one on your hard drive or your thumb drive or wherever you save it to. You make changes to it, it makes changes to the copy in RAM, and it doesn't go out to the one on your hard drive until you save it again. If your computer starts running sluggish, because you got a bunch of applications running, which is called multitasking, maybe you need more RAM, because the way RAM works is when it starts getting full, it will automatically copy the least used commands out to virtual memory. And if you decide to use that, then it automatically copy it back in there and move something else back to virtual memory. Now, this is done in the background, so we never know that. So, for instance, if I'm doing a mail merge in Word, maybe that was copied to virtual memory, it automatically copies it back up, moves something else out there. And of course, this is done in milliseconds, so we don't notice that much of a performance hit. All right, now let's talk about secondary storage devices. It's a type of memory that can hold data for long periods of time. Programs and important data are stored in secondary devices. Disk drive is a common type of secondary storage. It is stored by magnetically encoding it onto a circular disk. Most computers have internal disk drives. Of course, you can also get external disk drives if you need it. Solid-state drives are becoming increasingly popular. It does not contain a disk. Instead, it stores data in solid-state memory. There's no moving parts, and it's faster than a traditional disk drive. USB drives are small devices that plug into the computer's universal serial bus port. Most hardware that you purchase now comes with a USB drive to hook it up. For instance, if you buy a new monitor, a lot of times it hook into the USB port. If you buy a mouse or a printer or an external disk drive. The USB drive does not contain a disk. The data is stored on flash memory, also known as memory sticks or flash drives or thumb drives. They're inexpensive, reliable, and they're small. CDs or DVDs are optical devices. Data is encoded in a series of pits on the disk surface. It uses laser to encode the data, holds a large amount of data, and good medium for creating backups. Cloud storage, that's what the industry's pushing now. They want you to store stuff on the cloud. It's where you store data in the cloud. You're storing it on a remote server via the internet or via a company's private network. You can access it from many different devices and from any location where you have a network connection. Can also be used as backup important data. Input devices. An input device is any device that allows you to input information into the computer. The hardware component that collects the data is called the input device. Common input devices are the keyboard, the mouse, the touchscreen, the scanner, microphone, and digital cameras. There's quite a few different other types of input devices, such as a retina scan, a thumbprint scan, and so on. Can you think of any other input devices? Output devices. Any data the computer produces for people or for other devices is called output. The hardware component that formats and presents the data is called an output device. The most common are monitors and printers. Can you think of any other output devices? Software. Everything a computer does is controlled by software. There's two different categories: system software and application software. I was at a training many years ago at IBM, and one of the guys said that the only thing wrong with computers is that they're so dumb they'll only do what somebody tells it to do. And if you think about it, that's exactly true. You turn on your computer, it's going to sit there and stare at you until you tell it what you want to do next. You open up Microsoft Word, it's going to sit there and wait for you to tell it what to do next. It's an interactive process. And the people that tell it what to do next, as far as after it's running, is users. But the ones that allow the system work are system software programmers and application programmers. System software, programs that control and manage the basic operations of a computer, is the system software. It includes operating system, utility programs, and software development tools. Application software, programs that people normally spend most of their time running on their computers performing everyday tasks. For example, of course, they show you the Microsoft Office products. There's millions of different type of application software. All data that is stored in a computer is converted to a sequence of zeros and ones. That's all the computer recognizes. I type in an A on my keyboard, an A shows up on my monitor, but internally, all the computer sees is a group of zeros and ones. A computer's memory is divided into tiny storage locations known as bytes. 1 byte represents one number. A byte is divided into 8 smaller storage locations known as bits, binary digits. Bits are tiny electrical components that can hold either a positive or negative charge. A positive is on, a negative is off. Figure 1/6 shows you what it looks like. 8 bits make up a byte, and that's what that figure is showing. Storing numbers. The way this works is, see down at the bottom, figure 1-8, like the one to the right, that represents 2 to the 0 power. The one next to it is 2 to the first power, and then 2 to the second, and so on. See how you do 1 to the 0 power is 1, and 1 to the first power is 2, and then 4, 8, 16, 32, 64, 256, 512, 1024, and so on, all the way up to 3276. So for large numbers, it used 2 bytes, and it'll go up to 65,535. Let me go back for a minute. All right, so that's where they come up with the number 157 here. The first bit is on. That represents a 1. Then the third bit represents a 4. Fourth, 8. Fifth, 16. And then the last one, 8, is 128. So you add them together, that's 157. Characters are stored in computer memory as binary numbers. ASCII, American Standard Code for Information Interchange, is the coding scheme also used. The letter A is represented internally by a 65, which this is what it would look like in binary. Remember, a capital A is represented different than a lowercase a, and so forth, and so, as well as all the other letters in the alphabet. ASCII is a set of 128 numeric codes. It's limited. Unicode is the one that's the industry standard now because it includes a lot of the symbols for the languages from other countries. Advanced number storage. Binary systems can use to represent only integers. Negative numbers are encoded using 2 complements. Real numbers are encoded using floating points. Other types of data is digital data. Data that is stored in binary. Digital device is a device that works with the binary data. The digital image are composed of tiny dots of colors known as pixels. Digital sound is broken into small pieces known as samples. How the program works. A computer CPU can only understand instructions that are written in machine language, which is zeros and one. Because people find it very difficult to write entire programs in machine language, other programming languages have been invented. The CPU is the most important part of a computer. It's not a brain. It's not smart. It's also, remember, it's an electrical device designed to do specific things. If in some books, it'll say the CPU is the brains of the computer. You'll hear both different opinions. This book says it's not a brain. Some says it's the brains of the computer. That's just where most of the work is performed on the computer. It is designed to perform the following operations. Read a piece of data from main memory. Do some kind of calculations, which of course is adding, subtracting, multiplication, or dividing. Moving a piece of data from one memory location to another. It can determine whether one value is equal to or greater than the other, or less than for that matter. CPU only understands instructions written in machine language. Again, that's zeros and one. The entire set of instructions that a CPU can execute is known as the CPU's instruction set. Each brand of microprocessors has their own instruction set. This talks about the fetch, decode, and execute cycle, and it explains it in Figure 1-16. Fetch is reading the next instruction in the program. Decoding the instructions is to determine which operation to perform, and execute is to perform the operation. So it'll go out and fetch it, then decode it, then execute it, and then it'll go back and get the next instruction, and so on and so forth until you get to the end of the instruction. From machine language to assembly languages. Remember, computers can only understand machine languages, but it's difficult to write. So assembly language was created to use short words known as mnemonics. The assembler was used to translate that to machine language. And Figure 117 shows you what an assembly language program would look like. Then it runs through the assembler and turns it to machine code. High-level languages. Assembly language is referred to as low-level language. High-level languages allow you to create powerful and complex programs without knowing how the CPU works, using words that are easy to understand. Java, C++, Python, Visual Basic, C++, Ada, and Fortran is some examples of high-level languages. Can you think of any other high-level languages? They have keywords and reserved words that have specific meaning and purpose for the programming languages. Operators perform various operations on the data, such as multiplication, division, addition, and subtraction. Syntax is a set of rules that must be followed when writing a program. Statements are the individual instructions written in the programming language. So what you're going to do, you're going to write a program in a high-level language. Compilers and interpreters. A statement written in high-level language is called source code or simply code. Source code is translated to machine language using a compiler or an interpreter. A syntax error is mistakes such as a misspelled word, missing punctuation character, or incorrect use of an operator. Compiler is a program that translates a high-level language program into a separate machine language program. Figure 1-18 shows you how that works. You type in your program, you run it through the compiler, it turns it to machine language. The CPU executes the machine language program. Interpreter is a program that both translates and executes the instruction in a high-level language program. It works similar to a compiler, except some languages you have to run it through a compiler, some languages you run it through an interpreter. The end result is you got to get all the syntax errors out before that program will run. Types of software. Programs generally fit into one or two categories. System software, which is a set of instructions that control or enhance the operation of a computer. Application software, programs that make a computer used for everyday tasks. All right, now we're going to Blackboard, and you can see that in Chapter 1 assignments, all you do is read the chapter, then you do the quiz, the test, and the blog, and then you're done. The quiz can be done multiple times, and it takes the highest grade. The test can only be done once, and the blog, you have to do a post and then reply to 2 other students. If you have any questions, email or call me. I hope this video helps.